So all of you keep reading. Next concept we are going to study is motional EMF in rotating rod and as well as disc. That is what is our concept now. So it's very easy and simple. Just you must have little interest, you can understand. So motional EMF in rotating rod and as well as disc. Okay, everybody? Yes, please. All of you? Yes. So now
Yes, sir.
first let us imagine what we already studied motional EMF in a rod generally. So if I consider, so what we already studied, a rod is moving in a magnetic field. So let me consider a magnetic field. So what we already studied, guys. So just remember, now what is the direction of magnetic field? Everybody speak loudly. Direction of magnetic field into the page. Now imagine if a rod is moving with a velocity v, any direction, velocity v, who is having a length L. So we all knows that in these situations, the force exerted by that, which is equals to Q into V cross B, is it right or wrong? Please respond. Lenz's formula. All of you remembered or not? Yes?
Yes, sir.
Yes.
Sir,
What is the EMF induced in this, everybody? EMF induced. All are perpendicular.
B,
All are mutually perpendicular. So then what is the induced EMF is equals to? Speak loudly.
B,
Yes, please. Induced EMF E. Sorry for that. So induced EMF E is equals to what is happening? Speak loudly, guys. B into
B,
V into L. So a moving rod, a rod which is moving in a magnetic field. So definitely it will be turned up into a battery, or we wish to say it will be turned up into a, okay, because it will induce the voltage when it is moving across the magnetic field. Is it right, guys? But they must be in what? Mutually, they must be in what? Speak loudly. Yes, please.
perpendicular.
Perpendicular to each other. If they are parallel, any two are parallel, definitely the induced EMF is zero, which we already studied. Now, the same situation, we are going to, instead of moving the rod vertically or horizontally, we are going to rotate the rod in magnetic field. What are we going to do, everybody? We are going to rotate the, speak loudly. We are going to rotate the rod in the magnetic field. Do you all able to understand? So in this situation, so what is the EMF induced by the rod and how to calculate it? That is what we are going to discuss. So we start now, everyone. Please respond,
Yes,
guys.
sir.
So now, instead of movement, so till now we studied if a rod is moving in a magnetic field, the induced EMF is equals to B into V into, speak loudly, B into spin, E into L. Yes or no, guys? Yes. So now imagine this is the rod which is actually spinning, understanding? So this is the pivot point, so which has been attached. So please note it. So this is the rod which has been attached here and which is rotating here. Is it okay, guys? Which is spinning. So pivoted. If it is pivoted means then it will start doing the oscillation. Yes or no? I want answer. Yes, guys? Yeah. So it will start making the rotation. Is it okay? Yes, please.
yes,
Yeah. So I want to answer. That's the reason. So now it will start making the rotation. So revolution we can say. So it will spinning completely. It will spinning with the radius r. Am I right, guys? Now okay, everything matching. All of you understanding? Yes.
sir.
Okay. Again, I'll draw. What is that? Okay. So with the radius r, is it okay, guys? Everybody understanding? It will be spin or not? All of you. Yes, guys.
Yes, sir.
Is it okay, everybody? Yes. So it will be keep on revolving in this direction. Yes. So
Yes, sir.
imagine, let us rotate this rod in this magnetic field. What is the direction of magnetic field? Everybody. What is the direction of magnetic field?
Inward.
Into the page. Understanding? So now let us imagine it is rotating with the angular velocity. What is the angular velocity symbol? Omega. Okay. All of you. You understand, guys? So now, you tell me, does the each part will travel with the same velocity or different velocity? That is what is my first question. Everybody? Yes, please. Does each part of this rod will travel with the same velocity or different velocity? That is also a question. Yes, please. Travel with the same or different velocity. I am asking you. Yeah, please respond. In circular motion, it is rotating. It is rotating in a circular motion. So definitely it is a no constant velocity. Am I right or wrong? Velocity keep on changes as the direction changes. Is it okay, guys? I want to answer. Yes or no? So now, let me consider now several parts of this rod. I am considering, so this is my pivoted point. So where it is spinning. Now, does the each part, let me take, this is the part one. And this is the next part, next part, next part, next part, next part, and last part. Does the each part having the same velocity or different velocity? That is what is my question. Everybody. Yeah, please. I'm asking you only. Please respond. Whatever you know, yes or no, tell me, that's all. So now tell me, everybody, suppose if I take the point which is close to the pivot. So what is the distance covered by them? It's very, very small. Am I right or wrong? What,
Yes,
guys?
sir.
Yes. So the distance which is present on the surface at the end. So what is that? It will cover more distance or less distance? Everybody. No one. Hurry, respond, guys. I'm asking you only. It will insert more distance or less distance? That's my first question. Ah, everybody. It will travel where same velocity, different velocity, each part. At least for that you answer.
Different.
Velocity. Do you understand it? Because see that when they are moving here, vertically or horizontally, each part, if suppose this part will travel x distance, then this part also x distance, this part also x distance. So all the particles will travel the same distance. Is it okay, guys? Everybody? All of you clear? But if you talk about circular motion, each particle does not travel with the what? Same velocity. Do you understand, everybody? All of you clear? Yes. So that's what I say. So now, which particle will travel more velocity? So the particle which is closer to the pivot point, less. Next one little bit more. Next one little bit more. Next one little bit more. So when it will comes to the surface, the particle which is, so it will travel with the maximum velocity. Is it right or wrong, guys? I want to answer. Yes. So reason is what?
Yes.
The potential energy from the pivot point, if you keep on going, the PD, potential energy keep on increase or decrease? Keep on? Yes,
Increase.
please. Increases. All of you understanding? So that is what. Now, so here it is not the uniform magnetism. So we cannot find in ordinary way. So what is the method we have to do is, we already learned, everybody. Can you tell me anyone? Yes, please. Any one of you? So there is a method we can do it. Anybody, even 11th class, we have done it. So what will happen? So each particle is traveling with a different velocity. So the particle which has been considered here or here or here from the pivot point. So let me consider last particle. So this is my pivot point. So potential energy keep on going to what? Everybody. Yes,
Increases.
potential energy keep on going to increases. So rise in PD. So when it is moving away from the what? Away from the pivoted point. Do you understand, everyone? So now each point we cannot calculate because it is not same. So I want to break it into small particles, and total I will find it. So that where it will starts from 0 and finally it will ends from where? L. Is it right or wrong? I want answer. So what is the method we'll use it? Anybody can tell. There is a method which we can use it. Any one of you? No answer. I cannot do anything. Are yaar, small area like we are making, guys. So what is the method we'll use it for finding the total per year, induced EMF?
Integrate.
We can use integration. So now, let me consider, if I want to use integration, let me consider a small portion first. From the pivoted point, let the distance is x. So what is the distance, everybody? What is the distance? X. Understanding?
Yes.
So now, then the thickness of this part, let me consider what I can consider. Total is L. Then this thickness of the part I can consider as a dx. Is it okay, guys? All of you? Then total EMF which is induced is V. Then what is the smallest particle which is induced? Everybody?
dV.
dV. So dV is equals to what? We all know total EMF is BVL. Now the small particle, what will happen? B into L is equals to what? Speak loudly. Dx. Is it
dx.
okay? All of you understand? I want answer. Then we have to apply the integration. So then total. So total is equals to integral dV is equals to integral BV into dx. So V varies from where to where? Integral dV. Integration of dV is what? V. So now B is constant. Am I right, guys? I want answer. Then V varies or remains constant? V varies. That is what is our story. Am I right or wrong? V
Yes,
is
sir.
keep on changes or not? Velocity remains constant or varies? Everybody. Different velocity.
Very.
Yes or no, guys? That is what. So different velocity. So varies from where to where? From 0 to x equals to L. Is it okay, guys? All agree with me? I want response. Everybody? So B is equals to, V is equals to B into. So now see, is it possible to divide velocity with the dx? So we cannot do it. So same terms. So can you tell me V in the form of dx? Anybody? We can write in the form of dx.
dx by dt.
Yes, dx by dt we can write it, but do you all remember that? Everybody. So after traveling certain distance, definitely you can see. Suppose, let me consider the last particle or this particle. So let me consider here the velocity is v. Now when it will rises to the particular level, so that's what it is rotating. So definitely the particle will reaches to here. So it will form a something. What is that formula? Check it, everybody. Yes, it is forming the what? Arc. Yes or no? Everybody? No
Yes, sir.
answer. So which is with a theta angle. So this is radius r. So let me consider. So now this is the distance. So what is that, everybody? S is equals to what? I want answer. S is equals to what?
r theta.
R theta. Everybody should answer. It's not that one. So S is equals to R theta. Let divide both the sides with a T. So what will happen? This will become S by T is equals to R theta by T. So S by theta is equals to something. Anybody can tell?
v.
S by T theta is equals to what? V.
v.
Equals to. Same way. Theta by T is equals to something. Anybody can tell? Theta by T is equals to something. What is that? Yes, omega. Now here R only we used to call it as a what? R only considered as a what? X. So V is equals to X omega. Do you all agree with me, guys? Can't answer.
Yes, sir.
Yes. Pradosh, Mr. Rudresh, that is what. So B is equals to integral X W into dx. So here again W is equals to what? W is equals to remains what? Angular velocity remains constant. Am I right or wrong? So W is outside. So integration of dx. So integration of dx, what is the formula? Integration of dx.
dx.
Integration of dx equals to anybody? X square by 2. Is it okay, guys? Actually. Yes or no? Integration of x dx illa, sorry, x dx. Integration of x dx. Yes or no, guys? So what is the formula? Integration of dx is x. Integration of x dx, which is equals to what? X plus x power 1 plus 1 by 1 plus 1, which is equals to x square by 2. Is it yes or no? I want answer.
Yes, sir.
Yes. So which is equals to V is equals to B into W into, so it will become L square by 2 minus 0 square by 2. So what is the formula, everybody? I want answer. Induced EMF. Induced EMF when a rod is rotating, which is equals to what? B into omega into L square divided by what? Speak loudly. Yes, guys. By 2. So this is the, what is this? Motional EMF when a rod is rotating in a magnetic field. Hope you all understanding. Any doubt, anybody can ask me. Very serious, guys. Yes, Mr. Rudresh.
Yes, sir.
Yeah. So do it, please. I want response from everybody. So are you able to complete or not? Once you understand, please let me know. You proceed, and then we'll continue. Mr. Monish, understand, Monish? Induced EMF. I want answer, Mr. Monish. Hello guys, clear?
Yes, sir.
Yes, sir.
Kadri Purima Kadri, Murali, Narayan, Princey.
Yes, sir.
Yes, sir.
Okay, now. So now instead of this, if I put a disk, so then what will happen? We'll discuss everybody. Are you all okay? Yes, guys. All of you?
Yes, sir.
Yes, sir.
Yeah. So let me take now again the magnetic field, which is acting where? Everybody. What is the direction of magnetic field? All of you? Into the page. Understand?
Into the
So now, imagine I have been placed a disk in that. So any doubt anybody can ask. So I've been placed what everybody? A disk. Okay. Whose radius is R? Whose radius is what? Whose radius is what, guys? R.
R.
Okay. Any problem for anybody? You can ask me. All of you understand? So now, this is the disk which has been placed. So imagine the disk is rotating with angular velocity. What is the angular velocity? What is the angular velocity? Omega.
Omega.
So where magnetic field is acting into the page. Any problem for anybody? You can ask. Are you clear, everyone? Yes. Yes, guys.
Yes, sir.
Now, if I take a disk, generally, can I cut this disk into millions of particles? Anybody? Is it any problem? Any millions of slides? Yes or no?
Yes, sir.
Yes, sir.
Yes. So now, let me consider a single slide because millions of rods is joined, then only it will form into a circular one. Is it okay, guys? I've taken a one rod. Consider a piece. Consider a piece. Okay, consider a piece means like a rod spinning. Is it okay, guys? Is it looks like a rod or not? Exactly what we studied till now. Yes or no? Yes? Nobody answers.
Yes, sir.
So now if you all notice it, let's consider a piece of like rod. So like rod, if have been considered like a spinning, does the each particle is rotating the same distance or different distance? That's my first question. Immediately, everybody. Yes, imagine. So
Different.
after certain time, this slide is that came here. Now after certain time, this slide is came here. Now does it each particle is traveling the same distance or different distance? That's my first question. Everybody. So
Different.
here, then here, then here, then these particles. Does it they're traveling same distance or different distance? Everybody speak, respond.
Different.
Different distances. So then you can tell me, same like rod here also, then what is the induced EMF? Which is equals to B into W into L square divided by, speak loudly, guys. Do you all understand it? All of you clear? So different distances it is traveling
Yes,
with
sir.
angular velocity omega. So that what will happen? So for this also induced EMF is equals to like what? A rod is moving in a where? Magnetic field. Is it okay, guys? All of you understanding? A rod is moving in a magnetic field.
Yes, sir.
All of you clear? Yes. So at a particular radius, if I have been taken, so now particular check it, everybody. So for example, with this radius, I'm keep on checking throughout. Does the potential difference same or varies? That's my first question. Everybody. At a particular distance. At a particular distance, throughout the disk, what will happen? No answer.
Same.
At a particular distance, each particle is traveling the same. So that what is the potential difference? Everybody. PD will be what? Potential difference
Same.
is what? That is what. PD will be same everywhere. Everywhere it is the same in a given distance. Is it okay, guys? Yes, I want answer.
Yes, sir.
Yes. So now if you all observe very carefully here, the most important thing. Have you checked it now? Each particle, if I have been considered, let me consider this particle, above slices, above. above, one above another one above another one above another one. So can you tell me? They all are attached. So what connection it is? You might be remember from 10th class or no. So they all are attached one another. Yes, guys, at a particular radius. Imagine tiny batteries. Am I right or wrong? All of you, I want to answer. Yes, guys. So if you imagine this one, so I'm imagining this is the like a slit. Okay, we can say it's a slit. So this is the I'm imagining again what everyone small batteries. Next one small battery. Next one small batteries. Next one small. So they all are, if you notice it, at a particular radius, the PDs remain same or different. I want answer from you all people. Potential difference remains same. Do you understand everyone? All of you clear? So now imagine if there is a tiny batteries. That is what I have drawn here. So all the batteries, all are connected is actually in what connection? Everybody should answer.
Parallel.
Parallel connection. So we all knows that in parallel connection, so what is going to happen? Voltage. Voltage, it will be going to be add up or won't be going to add up. I want answer. A parallel connection, what is going to happen, guys? It won't be added up. Do you understand, everyone? Yes, please. So does there any change in voltage? Potential parallel connection, parallel connection, is there any increase in or decrease in voltage? Which is remains constant?
sir.
Parallel connection. Parallel connection, which is remains
Voltage.
constant. The voltage is V is remains constant. What is V? Voltage. So voltage is remains constant. All of you understanding? Yes. So now from inside to outside, everywhere voltage is remains constant. So what does it mean? Means from everywhere, from inside to outside, from the center to the here. So everywhere it is, what is happening? It is having the same potential difference. All of you understanding, guys? From inside to outside, V is remains same. All of you please respond. Okay, yeah? Yes?
Yes, sir.
Yeah, for a disc or a rod which is rotating in a magnetic field, the formula is same. So what is the formula? Yes, Princey. V is equals to B into W
B
whole square divided by 2. Is it okay? You all understand? I want response from each one of you. Yes. So if you all understand this, then I'm going to introduce the most important concept. That is what it is. Eddy currents and their applications. Eddy currents. So we'll learn what is eddy currents, and then we'll enter into the, actually it is not there for you. So, but it is important only to learn. So because as we are all using the inductors in our home, are you all using inductors in our home? I want response. Inductors, rice cookers and all inductors theriyada. I want response. Yes, please. Hello.
Yes, sir.
Yeah.
Yes, sir.
So inductors, we all knows that how that inductors will work and how it is going to happen. So we'll discuss now. So I'll show you the video and then we'll go with our most important concept. What is our concept? Self-inductance. So shall we start now, everyone? All of you?
Yes, sir.
Yes. So this is the most important about
cooker at home.
ED currents and as well as and their applications. So in our real life, we are able to see the transformers in our surroundings and rotating discs and all. So to understand this eddy currents, because imagination is very important. That's the reason I'm showing you. Because after that self-inductance, you can easily understand. So now to understand this one, so let us see eddy currents and their applications, how beautiful it is. And you should understand this one. Then only we'll go with the water inductors and what is the self-inductance. Okay, guys, everybody? If you're all okay, I'll proceed now. So let's start now. Yes.
Yes, sir.
I'm boiling water, and I thought the way it worked was like an iron box. The base would just get hot, and that heat would get transferred to the vessel and start cooking whatever's inside. But then I read that that's not how it works. The base of the induction cooker does not get hot at all. And then I tested it out. I took the induction cooker, I switched it on, and then I put my hand on top of it for a few minutes, and nothing. It wasn't hot at all. It was right. It doesn't produce any heat. But then on that same thing, I keep this vessel of water, and within minutes, it starts boiling. So the question is, how does an induction cooker cook things and heat things up without itself getting hot? Well, that's what we're going to find out. And it turns out it's due to the magic of, science of eddy currents. So what are these eddy currents? To answer that question, let's look inside the induction cooker. If you could open up, then you might see a lot of things, but the most important one is a coil.
Have you seen the coil? Copper coils, everything inside? I want response. Everybody? Yes?
Yes, sir.
Yeah. So what they'll produce? When the current is passing through them, definitely they'll produce something. Anybody can tell? Yeah, what they'll produce, guys?
Magnet.
They'll produce the magnetism. Understanding? So that what magnetism? Constant magnetism or variable magnetism? Everybody. Constant magnetism or variable magnetism? Variable? Variable. Who will induce the current, guys? Who will induce the current? Anybody can tell? Variable EMF or constant EMF? Please respond, guys.
Variable.
Variable EMF. So let us see that now. That is what is here.
At the center. And we know that when you pass current through the coil, it produces a magnetic field. And that's exactly what happens. When you turn on the switch, there's a current that starts passing through the coil, and that current starts generating magnetic fields. But what's important is that the current is fluctuating. It's changing its direction continuously. It's called alternating current, which we'll talk about in separate videos. And it changes its strength. As a result of that, the magnetic field that it generates also keeps fluctuating in direction and in strength. So imagine this is how the magnetic field is generated. It's continuously fluctuating. And that's all that our induction cooker does. It does not produce any heat. All it does, it produces a fluctuating magnetic field. But how does that boil our water? We'll get to that eventually. But for now, instead of thinking about keeping a vessel on top of this, let's keep a rectangular loop of water.
Now you tell me with your knowledge. So now there is a change in induced EMF. So because of that, definitely it is going to, what is going to do? Anybody can tell? It is going to induce the current in this rectangular loop. Am I right or wrong? Please respond. So the EMF which is produced here, yes guys? The EMF which is produced here is a flexible EMF. So flexible EMF always it is induce the what? It will induce the current, yes or no?
Current.
Yes?
Wire.
Yeah, please.
What would happen? Well, because the magnetic field is fluctuating, we have changing magnetic flux through a coil. And from Faraday's law, we know that that produces an EMF. And as a result, there will be an induced current in this coil. Now, the direction of the current will all depend upon whether the magnetic field is increasing, decreasing, what the direction is in terms of Lenz's law, something all we have talked about before. But don't worry too much about the direction as of now. What's important is there is an induced current due to the changing magnetic flux. But now comes the question, what if instead of having a coil like this, what if we had kept a rectangular plate?
Now you tell me, here what is that? It is like a, you can see that, open one. It is open ring, like a ring. Now it is becomes into what, everybody? Now it is becomes into what? A solid one. Am I right or wrong? Please respond, guys. So now current is induced before when it is a rectangular loop. Current is only induced on the loop. So rectangular loop. So it is going. Now it's become into a plate. So plate means then current will start passing through every part of it. Is it right or wrong? I want answer. So current will start passing through the induced current will start passing through every part of it. That is what which we used to call. It will be started spiraling, like it will be like a rotating rings. It will be forming. That is what we used to call it as eddy currents. You can see that.
Now what would happen? Well, again, the flux is changing, so there is an induced EMF. But earlier, there was only one path for the current to flow, but now the entire thing is a conductor. The whole thing is a playground for the electrons, which means your currents will be formed in loops everywhere on the surface of this conductor. And so you'll have loops of current formed on the surface. And these loops of current, which are formed on the
What they are called it as? They are only called it as what currents?
surface of a conductor due to changing magnetic flux is what we call eddy currents. And I thought that these are called eddy currents because maybe some guy named Eddie discovered it because that's how most of the stuff works in physics. But they're called eddies because they're swirling. So if you consider a whirlpool of water, something that's swirling, they're usually called eddies or vortices. And since this is very similar to that, we call them eddy currents. But how does that produce any heat? Well, of course, current produces heat. We've learned that before. When current flows through a wire, the wire heats up. Now there is current everywhere on the surface of the conductor, which means this whole metallic plate heats up. So if we go back to our vessel of water, due to the fluctuating magnetic fields, eddy currents are set up on the base of this vessel. And that's how the vessel gets heated up directly. And then that heat is transferred to the water, making it boil. Well, then why doesn't that same thing happen to our hands? Well, that's because our hands are not all that great conductor, and therefore the eddy currents formed are incredibly microscopic and they'd hardly have any effect. So in short, these induction cookers generate fluctuating magnetic fields, and when there is a conductor nearby, it experiences a changing magnetic flux that induces currents on the surface, which we call the eddy currents, which heat it up, and that's how you can have induction heating. Incredible, isn't it? But wait, before we start parting, doesn't it mean that whenever you have conductors and changing magnetic fields, you will have eddy currents, and as a result you will have heating, even if you don't want them? Yeah. Wouldn't that be a problem? What if you don't want that to happen? How do you reduce eddy currents when you don't want them? Again, going back to our metallic plate, how do we reduce these eddy currents when we don't need them? Well, we can reduce current by increasing the resistance of our metallic conductor. We know more resistance means less current. How do I increase the resistance of this conductor? Well, one of the cool ways of doing that is by introducing slots like this. So kind of making it like a comb. In doing so, think of what we are doing. We are introducing air in between, and air is an excellent insulator, which means the overall resistance of this now has increased tremendously. And as a result of that, the eddy currents now have reduced tremendously, which means less heat loss. And this also means now there is less area for the current. So you'll have tinier eddy currents. And again, because of this, we'll have less heating effect. And a practical application of this is seen in transformers. Now the details about the working of transformers is something that we'll tackle in a separate video. But the important...
No, that's fine. That is enough. Now, do you all understand what is eddy currents, everybody? All of you?
Yes, sir.
Yeah. So eddy currents means the currents, which is like we can say that is spirling currents, where rotating like eddies. So now generally inductance will work with the same principle. So now here what we are having that just to know the importance, and transformers you might be notice it. So is it my screen is visible, everybody? Word document is visible, all of you? Please respond. So now transformers
Yes,
which have
sir.
been taken, so you might be notice it, there is no single metal which has been placed like this. The reason behind is, so single metal it won't be placed behind it. To what? What is the purpose? To reduce the eddies, what they will do means, they will take a slices. So metal slices they will be taken, and one after one they have been arranged like a parallel, like one after one parallel, which have been insulated. So each plate is insulated, so that one plate to another plate, so there is a air gap. That is what strips, air strips. So that we all knows that air is a what? Very, very good conductor or bad conductor? Very, very insulator. Am I right or wrong? It's a very bad conductor, air. Yes or no, guys? Please respond. So that
Yes, sir.
it will help to reduce the what? Eddies. So our transformers generally we are using, that is the principle, eddy currents principle is only we are using to transfer like increases currents and all by reducing that okay, resistances. Resistance, we all know resistance and currents both are inversely proportional to each other. Resistance increases, current decreases. Current increases, resistance decreases. From the Ohm's law. Do you all remember, everyone? R is equals to V by I. Yes or no, guys? So that is what is actually what is eddy currents. Hope you all understand. I want response, please. All of you? Yes. So that is how the eddy currents will produce, and their applications will use in transformers and all. Now I am going to enter into the most important concept. Am I audible? Please respond. That is what we used to call it as inductors. Okay. So what is inductors, and as well as the most important one is self-induction. So let us discuss it. Self-inductance. So shall we start now, everyone? Yes. All of you?
Yes, sir.
Yes. So nothing is there. Inductors means who themselves can induce, themselves can induce the voltage. Induce the voltage is called it as inductors, or we can say EMF. Okay, so when the voltage is induced, anybody can tell? There is a way when we can induce the voltage. Anybody can tell? Voltage is
Change in
induced. Respond. If there is change in, yes, please. Constant magnetism, change in magnetic flux. I want response. Change in magnetic flux. Okay, so change in magnetic flux only will help to induce the voltage. Yes or no, guys? I want answer. Yes. Everybody? Nobody
Yes,
answers.
sir.
That is what. Now, let us imagine there is a simple electric circuit where a bulb is there and there is a battery or a dry cell which is connected to that. Now, if I on the switch, immediately what will happen? You can see the bulb which is glowing with the maximum brightness. Am I right or wrong? I want answer, please. Yes, please. So let us imagine the induced current in that is 1 ampere. So means, so positive, negative. So maximum directly current will shift from, if I on the switch, immediately current will shift from 0 amperes to how many amperes? I want answer. 0 amperes to how many amperes, guys? 1 ampere. Understand, Ra? Respond, Ra, everybody. So as soon as if I on the switch, immediately the current will shift from 0 amperes to how many amperes? Everybody, 1 ampere. Let 1 ampere current. Understand, everyone? So that bulb will glow with the maximum brightness. Yes or no, guys? Current reaches maximum, so it will go with the maximum brightness. Yes or no? Yes?
Yes, sir.
Answer? Everybody. So meeting is going to end, join back. Now, imagine, instead of this simple circuit, now, I will use a batteries. I'm going to attach a coil. I'm going to attach a coil which is wrapped around an insulator like electromagnet. Now, if I have been attached a bulb, so now does